Hi everyone, I would like to cover something which is very important and simple, be important, but maybe difficult for some of you. So I thought a video recording of a micro lesson on this thing called phase difference is important. So let's take a look at these two waves over here. So these two waves has a wavelength. They have the same wavelength, which is 2 meters apart, 2 meters wavelength. And these two waves, they are offset by a distance of 1 meter. So the path difference is 1 meter. Now, if I were just to tell you that the path difference is 1 meter without telling you the wavelength, you would not be able to tell whether they're going to interfere destructively or constructively. So if I tell you that the two waves are separated by 1 meter, is it constructive or destructive? You wouldn't know until you know the wavelength. So it is very important for us to know the separation of the two waves relative to their wavelength, which is what we learned about path difference equals to n lambda and n plus half lambda. So there is this quantity called phase difference, that is 2 pi times the separation in distance divided by wavelength, or it can be separation in time as a function, as a fraction of the period. So what does this mean? It means that if you take a look at this one, that if the separation is 1 meter and the wavelength is 2 meters, the phase difference will be equals to pi radians. Interestingly, if you were to take a look at two objects going round in circles, let's use this example over here. If you have these two objects like going round in circle in this direction, and I were to trace their y position as a function of time, can you see that for this particle x over here, it will be a sine graph, because it starts from 0, goes to positive y direction, and then it goes down to 0 again after half a period. And for y, it would be a cosine graph, because it starts off from the maximum y position and then it starts to fall down to 0 position after a quarter of a period. So what is more interesting is, can you see what's the angle between the two of them? It is 90 degrees, and we know that the phase angle between cosine and sine is 90 degrees. So how is this relevant to this pi radians that we talk about? So if two objects are 180 degrees apart, can you see that this, as it moves here and moves here, this graph over here we went through it is cosine, but this one is negative cosine. So you can see that these two graphs will always be opposite to each other at any point of time. So that's why when we say that two waves are pi radians phase difference apart, or they have a phase difference of pi radians, it means that they will add destructively regardless. I don't even need information about the path difference, I don't even need information about the wavelength. Which is why it is very useful, because if you take a look at this case, the path difference is 4 meters. Likewise, knowing a path difference of 4 meters is not very useful unless I know the wavelength, because 4 meters, if the wavelength is 12 meters, then it will be constructive interference. So I need to use this quantity called phase difference, and it's a very useful quantity because knowing that it is not, if it is pi radians out of phase, I know straight away that it is going to be interfering destructively. So phase difference tells us the state of the interference, which is a very useful quantity. And that's why we define this quantity called phase difference, which we'll be using it in the derivation that I'm going to show you in the next lesson. So this is a micro lesson on phase difference, a graphical representation, a more physical representation of what does phase difference mean. When we say that sine and cosine have a phase difference of 90 degrees, what does it mean? It actually can be understood as an exact angle over here between two objects that are 90 degrees away from each other. Alright, I hope you understand phase difference better, and the equation that you need to remember to calculate the phase difference is 2 pi times the separation in space divided by the wavelength, or 2 pi times the separation in time divided by the period. Alright.